All right, I see that the time is 10 a.m., so I think we're going to start, even though we are still having people coming in. Hello, everyone. Thank you for joining us today. Welcome to the MICROORC webinar about smart labels. My name is Bjørnsborg. I work in the communication department at Nofima, and Nofima is the coordinating institution of MICROORC, and I will be the host for this. This webinar is a collaboration between the EU projects MICROORC and Catalyze. And today's agenda is that we're going to hear a bit about MICROORC, the project. We're going to hear about current technologies, and we're going to hear from industry actors from Keep It, Innoscentia, and Mimica. And then we're going to hear some results from the MICROORC projects before we begin the questions and answers sessions. And finally, we hope to get your feedback after this webinar. And so the first speaker is Solveig.
Thank you. I will share my presentation. Yeah, can you see it now?
Yes.
Yeah. So I will just give a very short introduction to the project MICROORC, entitled Orchestrating Food System Microbiomes to Minimize Food Waste. And this is an innovation action funded by the Horizon Europe Research and Innovation Program and is coordinated by Nofima in Norway. And we have 17 partners across Europe in the project. The project is structured into three technical work packages, work package 2, 3, and 4, where we do the technology development. And work package 2 is maybe the most relevant today. It's about shelf life prediction and labeling of food. We also have 2 work packages about enhancing the shelf life of food, one about microbial preservatives, one about packaging solutions, and they're also collaborating. And we're developing the technologies for different food products, fresh chicken, fresh salmon, smoked salmon, and meat analogs. We also have 2 separate work packages for evaluating the technologies, one about consumer acceptance and social, economical, and environmental sustainability, and one work package looking at regulation and how regulation and policy may hinder the implementation of our technologies. So just to give some few examples, we are working with preservation technologies. We saw that now we have quite advanced packaging systems and materials, and we use synthesized or purified preservatives. And there are a few biosolutions on the market that are more acceptable for consumers. There are very few for spoilage. There are some for pathogens. We are developing biosolutions to inhibit the spoilage microbiota and have some good results from that. We also look at the packaging system that is not designed for recycling. We have quite advanced and complex packaging materials, and we need some simpler materials to be able to recycle the plastics. So we are now testing if we can make more optimized packaging solutions that can be recycled, but still keep the present shelf life. And so to the topic that are more maybe relevant just today and for today's topic, and that is date marking, that we feel should be more optimized for reducing food waste. Now all the food producers have to set a fixed date on their foods to say something about the shelf life, and this may lead to food waste. What we have found in our project is that the number of days before the quality is gone due to microbial growth varies from 12 to 27 days, and it will depend, depending on the batch and storage conditions. So we are working with the predictive and dynamic shelf life labeling to adjust the date for each batch and package. And today we're talking about this dynamic shelf life labeling and smart labels. And in autumn, we will arrange a new seminar together with Foodguard, talking more about predictive modeling of the shelf life. So that was very short about MICROORC. Please follow us at LinkedIn, and you can go into microorc.eu to read more about the project. So thank you.
Thank you, Solveig. And next up is Harri. Are you here?
Hello, hello. Greetings from Finland. Yes, here I am. I don't have the presenter permissions, so I cannot share. So Uda, you have the presentation.
I will share your presentation.
Yeah.
Can you see my screen?
Yep.
Just skipping. Yes, you just hit next for me. And I will...
Perfect.
Yeah.
Perfect. So yeah, coming to today's topic about the smart labels, I'm going to present some of the technologies behind smart labels, and later on we will have a chance to hear from the companies actually. So not going to the details of that, but yeah, next slide. So thinking about the definition of smart label, and now in this, let's say in this food products context, what is a smart label? So smart label is actually a product that is communicating the freshness of the food product based on measured conditions. And these measured conditions could be, for example, temperature, which is usually it is, and time. So we have this, I will later on introduce this product for this. But it can be also measurement of gases, measurement of pH, measurement of microbial activity, anything that is giving information on the product freshness and quality. The smart label is that we have this let's say measurements rather than fixed estimates of the use by date, for example. But the smart label is novel materials, components, and systems which are extending the functions beyond this kind of just visual text and graphics. So that's the main idea. So we have something else than just text and graphics there. Usually they are performing actions as a part of wider information systems. And also together with another products. And it's highly multidisciplinary, so we are combining new technologies, new applications, and new markets there. So that's the smart label. And on the next slide, now going into the current technologies. So this is the current situation with the labels. And some might call them smart labels because you can get information out of those. Yes, they are smart labels. You can see the product, the content of the product. You can see there's this barcode which will give you information on the logistics, for example. You can have even a QR code like in the other picture there, so that you can get more information on the products throughout that QR code. But these are fixed. So you have a fixed date, you have fixed information there, and not related to the product freshness that much. And that's why you create those, as you can see, those orange flags, so that you have to sell them with the cheaper price because the use by date is coming, and so on. Next slide is going more into the smart label technologies, these kind of indicators for different things. And like I said, later on we will hear about these great technologies more. But there are different type of indicators. Usually, I would say that there are time temperature indicators. They can be gas indicators, other types of things, but indicating the freshness of the product, for example. These are really good products, cost efficient, and in many ways really usable products. But next slide. Going into the more, let's say, sophisticated ways. So these loggers are available. So Sometimes they are not exactly a label type. So when we are talking about smart labels, these are not always label type, but still you can find this kind of a relatively thin and applicable to the food product, for example, measuring, for example, temperature and logging the information. So creating the smartness of the product. But sometimes they are not real time, so you cannot get the information whenever you want it. But once you receive the product, you can read it by plugging it into a computer or reading with the NFC or RFID. So that's a bit of a problem there. But from these, we can move on to the even more sophisticated and more real-time smart labels. And on the next slide, we will have this. So on the left side of the image is one product that could be used for measuring, for example, temperature or humidity of the product. It's a bit bulky, so it's not like a label type as we call it, but still it's a product for that, and it has a Bluetooth connectivity. So that creates the smartness again, to have like a real-time connection to the gateway and cloud service and providing the information in real time. So that's one of the ideas. But to be more as a label type, we have to use, let's say, different kind of technologies to manufacture these labels. Printed electronics being one of those technologies. So you are actually being able to create what was previously this kind of a rigid, bulky one into a flexible, thin type of structure, creating it more like a smart label, as we call it. You have to use different technologies. So for example, these electronic shelf labels on the top right corner, you can see one from Invisible, this kind of simple displays which can show this kind of, for example, dynamic shelf life of the product. You have to use new technologies for sensing and to create the platform for this kind of a label type. But from these technologies, you can create this kind of a smart label, which is real time, it's sustainable, it's cost efficient to manufacture, and so on. So that's basically the idea. The next slide shows a couple of, let's say, more of these technologies. I will not go into the detail due to the sake of time on these technologies, but there are several technologies behind these smart labels that could be used. Some of them are already explained. There are some, let's say, more conceptual things that would be really, really interesting and nice and important to have, but unfortunately technology is not there yet. But the development continues, so we will definitely most likely have those in the future. And the last thing on the next slide. So regarding these smart labels, it's not only the hardware which is directly attached to the food product, but of course there needs to be this kind of a database integration behind, so that we have the physical product, the smart label, but the smartness, the intelligent features come from the fact that you have this kind of a real-time connectivity or some ways to make it into the database, and in that you can have some sort of a calculation, for example. But yeah, that was briefly and quickly about the smart labels, and later on we will hear some more from the industry. Thank you.
Thank you, Harri. And we will move on to Peder.
Yes, thank you. So my name is Peder Bruusgaard. I'm the country manager of Keep It. So Keep It has been commercialized since 2012 with the indicator that you might have seen before. Right now, we're not having that product in the market anymore. We're now in the R&D phase of this new indicator that you're seeing on the page. But let's start from the beginning. Next page. It's all about solving the date stamp dilemma. We know there's, the date stamp is static. It doesn't really adjust for temperature deviations in the cold chain. and assumed temperature and time. And we know for a fact it's never 4 degrees all the time in the cold chain. Sometimes it's warmer, sometimes it's colder. This creates an uncertainty both for the producer, the retailer, and the consumer. And that also means that the producer needs to create buffers in their shelf life that range between 1 and 5 days, which again creates a lot of unnecessary food waste. So next page. That's why we've come up with this solution. So it's a real-time shelf life indicator showing the actual degradation of a fresh food product based on actual time and temperature. And in this way, you will secure food quality, safety, and reducing food waste. So next page, please. So how is this solving the dilemma? Well, let's say you have these two packs. They are completely the same. They are going out on the date stamp today. But on the left side, you'll see our indicator is already gone out. It's white. So that means the store manager should not sell it. The consumer shall not eat it. The cold chain has been warm, so it's already outdated. On the right side, the cold chain has been good, so you have more days, so you can sell it, you can eat it, and you can actually eat it after the date stamp is still safe. All right, so next page. This creates a lot of value for the retailer and the food producer, because now there's no more blame game between the food producer and the retailer, because now you have control of the cold chain and if there's been a breach in the cold chain. You get better shelf life management. You can cut out the buffer, so you get longer shelf life. And if you have a good cold chain that's maybe colder than 4 degrees, well, then you'll have more days to sell it and eat it. This will increase your profitability by reducing your food waste. And obviously, there's going to be some consumer and environmental benefits on this, such as next page. So for the consumer, they can see, you know, the product's been stored correctly. They can be sure about the quality. It creates trust, and they can tell you if your fridge at home is too warm. You can safely eat it after the date stamp has passed. And in this way, you'll avoid eating harmful food. You throw away less, you save money, and you do something right for environment. You have an actual tool to make good decisions. Okay, so next page. So how does this really work? Well, the indicator is mixed and printed, tailor-made to each specific product. So it's not a one-size-fits-all, it's all tailor-made to each specific product. The smart ink that we have is laminated between the two layers in the top film. So it's not in contact with the food. The great thing about this is it's self-activating through the humidity that is emitted from the product. So that means that you don't need any additional material or capex investments such as machines. It's just a plug and play. And obviously the content of the indicator is food grade and it's recyclable. Next page, please. We have partners in our Smart Ink in Germany, and we have a printing house in Lithuania that helps us out in this R&D phase at this moment. But in the future, hopefully anyone can use this, all the printing houses. Okay, next page. So the indicator we see in the top right is the one we've been in the market with for many, many years. And this new version will be easier, better, and more affordable because we managed to cut the price in half of the indicator itself. But now you don't need an applicator machine or any service or anything. So the price is much, much lower versus the prior version. And with printing, you have a lot of flexibility in terms of how the indicator should look like in, you know, form, shape, and type. It's a lot easier to implement, and the environmental benefits are huge, and it can also be used for monomaterials. So that's great. Yeah, next page. So the opportunities as a conclusion is, reduce food waste through potentially extended number of sales days, increased sales and profits, and you can always secure that the consumer get a high quality product, and it will position you as a customer, a pioneer in sustainability, because now you'll have a tool that tells you if you're doing a good job or not. It's like having you differentiate yourself versus competition as well. Okay, next page. So we've been something has happened to this page. Okay, we've been doing a multiple test with a Norwegian chicken producer, Norsk Kylling, and Nofima, testing different temperature and humidity levels. And what we found out, and we did this with a lot of different film lids. So what we found out was the speed differences in the indicator was quite big in some of these different lids because of the external humidity entering into the indicator. So what we needed to do together with Norsk Kylling and Nofima was to test the humidity levels across the whole cold chain. And you can see the results down to the right. So it's varying between 40 and 80%. You can see the temperature in the cold chain and how many days the product was there. So what we need to focus on now is actually an Alox film that is very tight. And due to this, we can cut out the external humidity penetrating into the film. So that's very good. We will also concentrating ourselves with the shelf lives that's a bit shorter, between 5 and 13 days. And right now we have a couple of customers in Europe that we're going to test and do pilots with the coming months. So hopefully we can be commercialized within, let's say, half a year if everything goes after plan. Yeah, so this is where we are right now. Thank you very much.
Thank you, Peder. And next up, we have Henrik. Are you here?
Yes, I'm here.
Great. The floor is yours.
Thank you. Do you see me okay in the video?
Yes.
Good. There is a high risk that we will be repeating ourselves because the problem we are trying to save between us and Keep It is, of course, the same. So there is a high risk of repetition in these presentations, I realize. But I will still try to make it interesting. So, hi everybody, my name is Henrik. I've joined Innoscentia as the CEO, and I'm having a great time doing that, trying to reduce food waste. So if we click, this will be some data that we already know, but global food waste is a huge problem, as we all know. I mean, it's $1 trillion problem or European euro problem. And in European Union alone, there is 132 billion euros being wasted every year in food waste. Of course, that's all food waste, and in equality, it's equal to 58 million tons as well. On top of this, we also have this EU regulation coming in that will demand the whole value chain to reduce waste by 10 to 30%. So, I mean, the world cannot really afford this waste, and the industry will be looking for solutions how to reduce it. And I think that's where we, as the project MICROORC, but also Keep It and Mimica and Innoscentia come in, because we are part of that solution. Because today, from all the learnings I have made, is that we, the consumers, we throw away a lot of food because we are uncertain about the quality. Please click again. I think this has been mentioned previously as well, but as you know, the mother of all learning is repetition, so why not go through it again? A big challenge today, as presented by Peder, is of course that since we cannot control the cold chain, we are adding a lot of safety margin to the best before date. And that is actually driving billions in waste. So when we have been talking to producers, we see 20 to 30% is being added as the safety margin, and that is creating waste in every step of the value chain. The producer have a shorter shelf life. The retailer, they will have a shorter sales window, and of course, then the consumer at home, they will sometimes feel uncertain when they buy something in the store, But of course, when they're trying to empty the fridge, like my son is doing, finding something in the fridge that has passed or is close to the best before date, they feel uncertain, and sometimes they throw away perfectly good food. So of course, this is the problem that we all are trying to solve. And we call that wasted value. It's wasted value both in terms of that you're wasting the food, but of course for the producer and the retailer, it's wasted value in terms of that they sometimes have to discount out the food to sell it. And that is a wasted value in terms of margin. Please click. So our solution is quite simple, actually. We have this sensor that needs to have contact with the food. And what it does is actually that it measures the biomarkers that is being released as food decays. As you have a spoilage process, the food, I will show more about this on the next slide. But as the food decays, you have a spoilage process, and that is releasing biomarkers. And since our sensor then needs to have contact with the food, I think that's a difference between us and Keep It. You are on the outside or in the layers, as you said. We need to have contact to measure the biomarkers. But as the biomarkers then hit a certain level, our sensor is actually changing color, as you can see here. So in the middle, it goes from yellow to red, and that is what we're doing with our sensor. So before, as long as the product is good, it is yellow, but then as the product goes bad, it actually turns red. And this is then a very easy visible signal for the consumer when they're buying the product in the store, but also at home in the fridge. I think that was everything on this slide. Please do next. And how does it work? Well, it's, of course, the science behind the sensor, that's very, very advanced. But how it works is actually quite simple. So what we're trying to show with this picture is that as you have spoilage over time, you see the red line here, that is the colony forming units, the log 7 as mentioned before. So as that grows, you also have the volatiles or the biomarkers growing, that is the blue line. Then what we're trying to show here is that in the middle of the graph at the bottom, you see it says best before date. That is typically then the 20 to 30% margin. But then with our sensor, what you can do is that since you can actually trust that you will have good product, you can move that best before date because it will then change as the volatiles and the biomarkers inside the package has increased. And then when they hit a certain level, it will actually turn color then. And again, the beauty here is that you don't need extra equipment or anything like that. It's something that every consumer can see in the store and at home. Yeah, let's click again. And again, I think the repetition will come here again, but since we can then expand the shelf life, we will release a lot of value throughout the value chain. We have the producers, they can extend shelf life. And as previously mentioned for Keep It as well, it's a differentiation on the market that you have this kind of quality sensor so they can reclaim the value. For the retailers, we see that this, of course, then translates into a longer sales window. And of course, that means that they don't have to discount as much if they do it. And also, if it passes the best before date, they can still show that it has good quality. They can actually reduce the amount of discount, the level of discount they have to give to sell the product. And of course, last but not least important, the consumers. As I mentioned before, they feel safe when they buy a product in the store, but also at home. I don't get the annoying calls from my son asking, can I eat this or not? Our sensor will then help the consumer know that the product is still good. Yeah, click. And I think that's it actually from us. And we call it trusted quality made visible in every package. That's sort of our slogan that we're trying to drive. That's all from me. Thank you.
Thank you, Henrik. And next up we have Solveig. Are you here? Or Mimica?
Sorry, I'm here we go. I'm here. Thank you very much. Should I share my I don't think I have the ability to share my slides. Or
I can share them.
Okay, no problem. I had some updated ones, but we will run with the ones you have. Okay, great. So thank you very much, everyone. It's a pleasure to be here. My name is Solveig, and I'm one of the founders of Mimica and our Chief Design Officer. Go to next slide. I won't dwell on this one too much because it was well covered, but yes, having to use cautious expiry dates to help protect consumers does drive enormous amounts of waste, and we know that up to 83% of wasted food in Europe is still perfectly edible, and unsold food is worth double grocery profit margins for retailers, so it's a very costly problem as well, and we know that food waste is one of the top drivers of climate change. Next slide, please. And so we see that there's an opportunity to help create better brand loyalty by increasing consumer confidence and trust and helping them waste less. People said that they would buy also bigger packs of food if they felt that they could use them in time. So the reality is that life availability is there, but we are artificially curtailing the usable life of food by working with the worst case scenario. Next slide. So what the impact might just even adding 2 days have on food. We know that we can cut household waste by 63%. We can cut retail waste in half, and we can actually increase sales by about 10% just by increasing 2 days. And there's many products where we can increase many more than 2 days. Let's go to the next slide. So why does this actually drive profitability? People are often surprised to hear about the sales lift, for example. So there's, as we heard from Keep It, there's longer time to sell it on the shelf before it gets wasted. And from the consumer perspective, seeing extra days on the product encourages them to buy a bigger pack size or to buy more because they will use it up in time. It represents better value for money, particularly on high like more expensive products like meat and fish. And then just confidence at home drives loyalty and return purchases. So at Mimica, we've worked to bring these things together and create a solution that helps unlock those lost days. Next slide. And it's called Bump. There are dynamic food expiry labels. The main difference between us and the other two solutions we've seen today is that our solution is tactile. So it's not changing color and not doing anything else like that. You just, it changes from feeling perfectly smooth to bumpy at the right time. So let's go to the next slide. Yes, so this is how you feel it. You rub your finger over the surface of the tag, and if it's firm and smooth, it's good. And if you feel a bump in the middle, then that means it has spoiled. So it's really easy to understand and use. Let's go to the next slide. Oh, where's my text? Okay. Yes, that's a big arrow pointing at the thing. So basically, we're not trying to replace the date. This is what this slide was supposed to say. We're not trying to replace the date. We are helping food producers print a longer date based on reasonable storage. So we help them we take their product and take it to our lab, and we retest more likely scenarios, because at the moment all shelf life testing is done at kind of more poor storage conditions. And so we look at that and we bring all of that into account and create a spoilage curve. And in most cases, we can actually physically print 2 days, 3 days, 4 days extra on packaging. So that's what helps drive those extra sales and reduction in waste. Let's go to the next slide. So the way our product works is inside the tag is our unique gel chemistry that we've developed, which is temperature sensitive. It's dormant, and then the label gets activated when it goes on the packing line, and that's when it starts becoming time and temperature sensitive from that moment. And we also calibrate the product to be specific to different food types. So if we go to the next slide, we'll see an example. So this is an example for a beef profile. So this is the shelf life testing that we do. We always do it at 3 key temperatures. In this case, it was 4 degrees to represent good or reasonable storage, 8 degrees, which is the current industry standard for shelf life testing. So we repeat that. And then we also do the test at 21 degrees, so room temperature. So that's kind of really worst case scenario. And this is what I meant by the temperature curve, spoilage curve, I mean. And then that what that gives us is 14, 12 or 6 hours, 14, 12 days or 6 hours. And everything in between, because obviously the temperature journey is never linear and staying at one temperature. So yeah, it kind of works with everything in between as well. Let's go to the next slide. So what are the benefits for kind of brands using bump tag? This is going to be not really a surprise, but yeah, we can see that people, this is after a trial that we did, for example, with a retailer in the UK on steak. We know that people want to see bump tags on their steaks because it gives them extra confidence in freshness. We actually saw that people would switch brands to ones using bump tags, so kind of maybe even buying more premium products. People did agree that they would buy steak more often because the risk of wasting it would go down, and most people would tell their community about the bump tag, which also means they're talking about the brand that they saw it on. So that's a really good benefit. Let's go to the next slide. And here are the numbers, but I just thought I'd bring in some kind of actual things that people said, that they feel like they're saving money, getting better value for money, and it's been a game changer in helping reduce waste in the home. Let's go to the next slide. So this is everything that we do this for. Here are some of the customer projects that we've worked on. There are several here that I can't say the names of because they're live kind of behind the scenes trials and about to become public, but here are the ones we are able to talk about. So we have two formats that we've already launched: the cap, which goes on drinks and bottles, and then the tag format, which goes on other things. That's been the main focus of this MICROORC project, the tag. It's particularly on chicken and salmon, and you know, we started working with industrial companies very early stage, even before launching, and that was really important to make sure that we're validating what the customers actually want and making sure that we can apply it, and doing lots of user testing with their customers. So this has now been tested by hundreds, maybe even over 1,000 consumers, following up and getting surveys from them and improving our product where we position ourselves as a user-centered design company, actually. And because while the technology has to be really good, it's really important that it's really usable and understandable by consumers. So we obsess over getting the exact 6 words right on the label itself, because people need to understand how to use it, having never seen it before, because smart labels are a new thing. So it will only be adopted if it's super usable. So that's another big area that we focus on. Let's go to the next slide. Here's just an example of like the date extension potential for various foods, but as I won't dwell on this too long, but you can see it ranges from 1 to 2 days up to 10 to 12 days, really depending on the product. So the potential can be really huge on some things. Let's go to the next slide. So yes, that's everything from me. I hope you have been inspired to join our mission to radically reduce unnecessary waste. And if you have any questions, I guess you can ask them in the chat. I'll be happy to share. Thank you.
Thank you, Solveig. Annette, you're next.
Yes, and I will try to present it myself, or take control at least.
Yeah.
Let's see if that works. Yes, I'll put my camera on also. Yes, hello everyone. I'm Annette. I work at Nofima in the MICROORC project. Thanks to all the teams who just presented their technologies. That was really appreciated. What I'm going to do now is I'm going to try to put the field a bit more into context. Let's see how I'm not able to shift.
I've given you control.
Oh, let me see. Okay, but how do I do it? Up, down, backwards, forwards. Nah.
Then I will press the button.
Okay, yeah. We all have heard about what the problem is that we're trying to solve. About 20% of the food made available to consumers is being wasted, and this wasted food represents significant amount of greenhouse gas emissions. And the current expiry date system is responsible for some of this unnecessary waste, since the true shelf life varies for various reasons. Next slide, please. Yeah, so there has been lots of writing in the scientific literature about intelligent packaging solutions, including these smart labels. And there are many claims that these have enormous potential and that there's a pressing demand for them, and that they show great promise and will play an important role in reducing food waste. So then you start wondering, why isn't this already implemented? And then what are the bottlenecks? Next, please. Yeah, so it sort of feels like this field still is very much led by technology-focused research interests. There are lots of papers about the sensors, what to measure, how to measure it, and how nice the signal looks. But there's much less attention to the biology, what the spoilage process actually looks like in real food. And the second gap is that it often stops at we can measure something and it doesn't follow the full pathway from signal to decision to outcome. So the signal is supposed to lead to reduced food waste and improved quality, but that only works if the people interpret the signal correctly and then act on it in the way that it was intended. And there's not necessarily a straight line from a nice signal to the outcome that we care about. So in the next slide, I have put several constraints. Regulation is, of course, an important one. In the EU, a printed date mark is legally required. So a dynamic signal can only supplement it, not replace it. And if the label says OK after the printed date, then retailers are not allowed to sell it. And consumers are then left wondering whether to trust the date or the label or perhaps their own nose. And if the goal is reduced food waste, the signal also has to come early enough to be useful. It needs to warn consumers or retailers before the product becomes unacceptable. So there's actually time to act, to cook it, to freeze it, or to put it on discount, for example. And the sustainability benefit is also not automatic. You have to weigh the food that is actually saved against the extra material, production, and end-of-life footprint of a label that would be placed on every pack. Then there's the commercial side of it. It needs to fit existing packaging formats and retail systems. And the value has to be clear to the actors who pay for it. And in the next slide, I show that it seems like the ones that have the incentives to introduce intelligent packaging, the technology developers, the researchers, and the policymakers that are trying to reduce food waste, they are not the ones that are paying. The costs and risks lie with the food producers, the retailers, and the consumers. So this is really a system level problem. And it's probably going to need policy support to be implemented at scale. And in the next slide, I have some technical realities that are not always acknowledged by the technology researchers. First, shelf life is not an on-off switch. It's a pragmatic compromise between several different factors, such as variations in consumer sensitivities, acceptable return rates, and brand positioning, and so on. So even a good sensor doesn't remove this 100%. There's there's always going to be some sort of uncertainty. And second, modern food packaging is already playing a major role in extending shelf life and reducing food waste. So anything that's supposed to measure the condition of the food directly inside a food package must work in modified atmosphere packaging, not in air. So this humid and CO2-rich environment is quite challenging for sensors, and testing of box sensors in air packaging, which I see a lot, that doesn't really carry over to real products. And finally, there are many pathways to food spoilage. It's not always the same thing that spoils a given product. The microbiota can differ between producers, between batches, and even individual packs. So 2 packs can have different shelf lives, even with identical temperature histories. And different microorganisms that produce different spoilage gas patterns. So no single gas sensor or indicator will pick up everything equally well. So even for a stable product, you could end up needing really heavy calibration and validation for each specific product and producer in order to perform much better than a simple fixed state. In the next slide, I show an example of how complex spoilage can be. So in this study, 7 different Pseudomonas strains, which were linked to spoiled fish, were grown in a model fish substrate at different temperatures. And the heat maps show which spoilage gases were produced over time. And the results show that even within the same genus, different strains produced very different volatile profiles, and those profiles also shifted with temperature. And this is in a simplified system with just 1 strain at a time. In real foods, you have a mixed communities and they can interact, and they're also influenced by temperature, packaging conditions, raw material quality, and processing hygiene, and so on. So this is difficult to capture with a simple label. So in the next slide, I shall show some labels, and this is to show that the concept of food quality indicators, it is not new. And these review papers that I read, they often list lots of commercially available smart labels. But when we looked for real ongoing use in retail, there was very limited evidence. And all of these labels have been launched, but are no longer available. And the reason could be that it's not enough to measure something. The signal has to be robust in real packs, and it has to fit the regulatory and commercial reality. So in the next slide, you've probably seen this curve before. It basically shows what often happens with new technologies, like that first we get really excited and we promise too much, and then reality hits and we enter the trough of disillusionment. And then finally, we figure out what works and for which applications the technology is useful. So now I think you can click forward to get them. Just continue. Hold on, 1, 2, 3, 4. Yeah. There's some signs that smart labels are near the top of the hype peak, but also several signs that we are sliding into this trough. Like labels being discontinued and people running into these real world constraints. So the big question now is to find out, where does this actually create value? And it will be really interesting to see what direction the field takes next, and which solutions will actually survive and end up helping us reduce food waste. Then the next slide. Yeah, I don't have a crystal ball. But maybe the future doesn't look like the one smart label on every single package. It could be that the intelligence shifts away from the sensors on the package and into system level approaches. And temperature, as we've heard, is one of the main drivers of shelf life. We already have digital temperature tracking. It's available. And if this temperature data is linked to retail systems, it can trigger practical decisions like automatic price reductions towards the end of the shelf life. Maybe this will create a clearer pathway to creating value for customers and retailers, and maybe it's also more viable from an environmental perspective. And then in my last slide, I tried to sum up. A good technology is not enough. It needs to create the outcome that we care about. Because of the microbiology of spoilage, direct spoilage sensing is probably going to be difficult for mainstream chilled foods. Temperature is easier, and it's going to be interesting to see what the system level approaches can do. And don't forget that the solutions need to be attractive to the users. They need to be possible, given the constraints we have, in real settings and at scale. And they need to be worth it, considering both the cost and the environment. And that's all I had. Thank you for your attention, and I'll be happy to take questions after the last speaker.
Thank you, Annette. I'm assuming there might be some questions for you afterwards. But for now, let's move over to the consumer. Valerie?
Yes. Hello, everyone. My name is Valerie Almli. I'm a senior researcher at Nofima in sensory science and consumer behavior. And I will present results from a digital survey we conducted in Europe to look into consumers' acceptance of shelf life indicators. So the background, I think we've had many presentations now, so I will not take a lot of time on this. But the background is that a lot of refrigerated packaged foods are on the European market. I saw some estimation of 30 to 35% by mass. And we know that temperature abuses occur in transportation, in retail, in domestic refrigerators. And partly due to that, the producers apply a safety shelf life margin when they indicate a static date for shelf life. So they know the product, if it's preserved at the right temperature across the cold chain, will actually be of good quality when the date is passed, but they still have to use this safety margin because of the abuse. So really, as it has been presented very much today, the problem is that the static date is not always matching the actual shelf life of the package. And on the other hand, we know that consumers rely heavily on date markings when they decide whether to consume or throw a product. The date marking is the only indication they have of the quality besides their own senses, so the appearance, the smell. So for something that looks fine, the date is really the only clue they have. And this could lead then to food waste of good quality products. But if there was temperature abuse, it could also lead to actually consumer dissatisfaction when the date hasn't passed and you open and it still doesn't really smell or look fresh. And in the worst cases, it could endanger food safety. So as we have seen today, different technologies are being developed for dynamic shelf life information. And I will not present these technologies as the companies have presented different examples. So what we wanted to do as part of the MICROORC project is to investigate European consumers' acceptance of such shelf life indicators. We constructed a survey with over 10,000 respondents in 10 countries. Norway, Sweden, Denmark, Finland, Germany, France, Spain, Italy, Portugal, and Hungary. So to span across North and South and a bit Eastern Europe. And we had different sets of questions using concrete product examples of refrigerated packaged food chicken breast fillets, smoked salmon, fresh salmon fillet, and plant-based burgers. We investigated consumers' practices and attitudes in different ways. But what I will focus on today is the part of the survey that focused on the indicators for dynamic shelf life. So we presented to the consumers 5 methods for indicating shelf life on packages. A dynamic shelf life indicator that shows the remaining number of shelf life days as time goes. A scannable QR code that links to an updated expiry date information as time goes. A color indicator that shows when the product has expired by changing color as time goes. And a tactile or touch indicator that develops small bumps on the label, which you can feel when the product has expired. And all of these were also compared to responses for a classical date label. So we asked consumers on these indicators, we measured how easy it is to understand, how much they would trust the indicator, and how likely they would be to actually check and use the indicator before consuming a product. So on this graph are the results of understanding trust and the likelihood to check the indicator for the 5 solutions. So the light blue bars to the right is the classic date label. And as you can see, it resulted in the highest understanding, trust, and likelihood to be checked. Bear in mind that this is the familiar solution. The familiarity aspect is very important for such, for the consumers. So it's not surprising that this scores very high, and that gives us a reference point. And then to the alternative indicators, the orange one is the dynamic indicator that shows the remaining number of days. And this is the one that scores then the best of the alternative indicator solutions with high understanding, trust, and likelihood to be checked, followed by the color indicator. And then followed by the QR indicators. These are quite highly understood and trusted, but a somewhat lower probability to be checked compared to alternative solutions. And for the tactile indicator, it was the one that was the least understood and the least trusted. And at this point, just let me point at the fact that it's very hard to communicate a tactile indicator in an online survey. Because of course, showing images of, for example, a color indicator that changes color is fine on a screen, but communicating how to feel a bump is very tricky on the screen. So please just bear that in mind when you see these results. Moving on, we also asked a question on willingness to pay. So we asked, compared to a product with only a fixed date label, would you be willing to pay a few extra cents for a product that also includes an indicator showing the updated shelf life of the product? And here we could see first that globally across the 10 countries, there were 27% of yes answers, 54% of no, they wouldn't want to pay more, and a quite large part that was unsure, that maybe would need to see and smell the product to be able to make a decision or be more familiar with these indicators. If we look at country level, we could see that the southern countries and Hungary, there was above 30% of people who would be willing, it was a clear yes, they would be willing to pay a few extra cents for an indicator, while in the northern countries, there was fewer people who would be willing, and all down to almost only 10% in Norway. So there is a different gradient of maybe reflecting different habits on the prices on the market, but also a different perceived need for such indicators to evaluate their food. At the individual level, the willingness to pay for a few extra cents increased with income, but also younger age and males were more willing to pay a bit more than women. Then in the survey, we also included a practical task to investigate this issue that also Annette raised of if indicators are on a product, they're not instead of a date, they're in addition to the date. And of course, they are in addition to also the smell and appearance of the product, the sensory aspects. So our question was, how would consumers balance this information, especially if they give contradictory information that the date has passed, but not the indicator, for example? So we presented different scenarios one-on-one according to an experimental design. And we told people, imagine that you're about to prepare dinner at home with a refrigerated package of, for example, chicken breast fillet. Based on the information provided, indicate if you would eat or throw the product. And I'm showing you here results for what happens past the expiration date. The question being, can indicators then possibly save food? So in the first scenario that I highlighted here, we have a past expiration date and there's a non-fresh smell on the product and a red indicator. And in this case, there's most people reject the product logically. But then in the same condition, but if the fresh was still smell, we see that 25% of people accept the product also past the date. So smell is important. But if the date is passed and the smell is unfresh, but the indicator is green, then we would have a 40% acceptance. So a potential of really saving some food past the date if the indicator indicates that the product is still fine. And of course, in the best case scenario here, where even though the day has passed, but both the smell and the indicator indicate good quality, then we go up to 82% of acceptance of the product. So due to time, I'm not going to detail what happens before the date, but if you have before the expiration date, but please just ask if you want some details. I'm just moving a bit fast. So to conclude and summarize, we have run a pan-European survey in 10 countries to examine the possible acceptance of novel shelf life indicators. And of course, when it's an online survey, everything is very abstract and theoretical. But this gives us an indication of which direction the market is and how people are thinking. As of today, with very little experience of these indicators. And we could see that the dynamic indicator that shows the remaining shelf life days was the most accepted of the novel indicators, and that was true across the countries. We could also see that traditional date labels, as of today, they were remain the more trusted, understood, and likely to be consulted information. Really meaning that the combination of a date, static date, and an indicator would, people would probably really look at both. And it could take time before they learn to mostly trust the indicator, for example, with familiarity. We could also see that willingness to pay for novel solutions was higher in Southern Europe and Hungary than in Northern Europe. And we could see that a green light indicator past the expiry date could lead to 82% of people still accepting the product if also the smell was fresh. Thank you for your attention. And I'm looking forward to the discussion following all these very interesting presentations, also from the former speakers.
Thank you, Valerie.